Hello teacher, myself Kundan Kumar, and today I will be explaining our project, that is improving deployment speed and reducing production issues with DevOps practices. Before we go on to the code part, let us see some of the tools which we have to install prior to that. First is Minikube. You might ask what a Minikube is. Minikube, it is an easy to use Kubernetes cluster and it is also free to use. That is, you can install it locally and use it how much ever you want. Next up we have kubectl. Kubectl lets us communicate with our Kubernetes cluster through command line interface, also known as CLI. Next up we have eksctl. You can skip this one unless you use mini you don't want to use Minikube and use the EKS, which is a Elastic Kubernetes service provided by AWS, or IKS provided by IBM. Next up we have Docker. Docker is very important as we will containerize our applications and push it to a Docker Hub registry. Now let us understand the code before getting into the DevOps practices which we have implemented. We have made a website application by using a Go language. In this Go language, in this website, we have home page, resource page, about page, and contact page. There are 4 pages, and we have given a listen and serve at the port 8080. And in the handle function, if it is /home, we have directed it to home page function. Home page inside the home page function, we have given a serve file under the static folder and home.html. It is the same for others as well, like /resource, about, contact. We have mentioned the functions for those as well. Now let us see our home.html. This is our folder, static. Inside that we have all our 4 HTML codes. This is our home HTML. Now let me show you the output and it will be more clear. To show you the output, in the Go language, first we have to build a binary file. In that case, if you are implementing it first, you have to go build main.go is the command you have to use. Then you can use go run main.go. After this, we have to access it. For the accessing, I will use localhost. Look, as you can see, I have used a localhost port 8080 and given a /home. So I have got the home interface. In this, I have introduced our team and the internship we have taken inside the Skill India, which is in collaboration with 5 companies. And in the about page, it is about our team and our contributions in this project, like what we have used. First is we have Dockerized, that is containerized our application. Next we have used Kubernetes, that is deployment service and ingress files. Then we have Helm chart. We have used Helm chart for packaging and deploying our application, as well as variabilizing our image, Docker image we have used. So it is easy for CI/CD process. Next up, we have used GitHub Actions for our CI part, and for CD we have used Argo CD. Okay, now let us look into the contacts. It is nothing but our team members' contacts, their phone number, email, and a GitHub link. Same is for others as well. Next, resources. Resources are the things we used in order to build our project. Like if I go into GitHub Actions. It will redirect me to the website of GitHub Actions, and I can refer this and understand what what GitHub Actions means and what it is. Now let us go into the DevOps practices which we have used into our VS Code. Now let me see where Dockerfile. Okay, here we are. Dockerfile, I have used a Golang as a base image since it is a Go language based application. Then we have made a working directory /app. Later I have given a copy go.mod. Go.mod, you might ask what it is. It is a same as if you know Python. You might have seen requirements.txt. It is the same go.mod. Let me show you what is in it. Go.mod here. See, it is just the Go version that we have used. Then we run and download all the dependencies. Here we have copied all the files from our source into our app working directory. Then we have look here we are. I have told first we have to build our Go application. That is, it will be stored in main and it will be in binary. As you can see here, I cannot access it. It is because it is in binary and we won't be able to understand anything. We have used multi-stage Docker image, so it will take less space and for security reasons as well. I have used alias as base, and I have given it copy from base, so everything from the above section will be copied in our distroless image. Then we have exposed the port 8080 because our application is in port 8080, and to run our application we have used /main. Now that we have understood the Docker file, before moving on to the next part, I want to tell you why I am using this output output screenshots instead of executing it. I have asked our teacher from Ask Me Anything session and told her that it will take a long time if I have to execute it. So I asked her permissions if I can use screenshots and explain it in these screenshots, and she said yes. Now we have used here we have used docker build and -t, and it will build like this in stepwise. As you can see here, everything that we have used in our, it will be same as what we have used in our docker build. See, you can see copying go.mod work directory /app. Every line of the code is successfully built, and you can see here successfully built and tagged. Now we know why we are using Docker. It is to containerize our application. Docker mainly has three main commands, that is docker build, docker run, and docker push. Docker build -t, it is the terminal. -t means. Then it is image repo. What image repo is? Image repo is the your username in Docker Hub. Docker Hub is a online open source registry to store our images. And here it is image file name. This is the image name that you want to give to your application image. And finally we have :tag. Tag is very important as it helps us to version our images in order to know which version this image belongs to. Next up, we have used docker run. -p means porting 8080 from our docker to 8080 to our local machine. IT interactive terminal, and this part is the same thing as the above. Then finally we have used docker push, and the same thing as we have mentioned about. Before docker push, we have to configure our docker with the docker hub registry so that it will be pushed into that Docker Hub. Since we are using Minikube as our Kubernetes service, this is our Minikube. First we have to start our Minikube, and you can see the Minikube status, type control plane, host running, and kubeconfig configured. Now let us understand our Kubernetes manifest. That is, inside that we have deployment, ingress, and service. First up, deployment. Deployment is mainly useful to represent the replicas. Replicas means how many pods you want in your Kubernetes cluster. That is, in this case we have used only one, and this selectors is very important. That is match labels go web app, as it will redirect the deployment.yaml to into the service.yaml. Then other than replicas, we have used we tell it which image to use. In this case we have mentioned it over here, that is go web app from this repository 18653, and the version will be v1. Before going on to the service, let me show you how our Docker Hub looks. This is our Docker Hub, and you can see over here this is our image, and below these are our tags. There are 4 tags in this case. As the first one we have given manually as v1, then as we do our changes through CI/CD, it will assign a random number, and for our deployment to understand these random tags, we have used Helm, which allows us to variabilize our image tag. I will show that in the code in the further steps. Now let us understand the service. Service YAML is very simple, as it mainly used to mention the cluster type. In this case we have used cluster IP. There are 3 types: cluster IP, node port, and load balancer. We can't use load balancer with Minikube, as it is locally run and not a cloud service. Cluster IP means whoever has the access to this cluster can access the application, and node port means who are inside the node can use the application. As the name suggests, it's very simple to understand. Next up we have ingress.yaml. Ingress, it's a which looks into the host. The main thing is the host. It lets us see if we access the host go web app.local, it triggers our ingress, and it is used for DNS services like a domain name service. We can give our application name in our local, which I will explain further. In order for ingress, we need a ingress controller, which we will install. First, as you can see here, we have used Minikube add-ons enable ingress to enable the ingress controller. Then we install ingress controller, which will look into our local browser, and if we access anything which is mentioned here, host, for this example, if I access go web app.local in my web browser, it will trigger our ingress.yaml, and which in turn will trigger our service.yaml, and this will trigger our deployment.yaml, and we can see fetch our image and we can look into our application. This is basic manifest of Kubernetes. Now let me explain you why we have used Helm. In Helm we will have like templates. Inside the templates you can see the same files: deployment.yaml, ingress.yaml, and service.yaml. But the one thing is, in the deployment.yaml, in the place of a tag we have used this. It is a variable .values.image.tag. This value will be updated through values that YAML. Sorry, my bad. Okay, yeah. As you can see here, the tag is mentioned over here, image tag. It is just a random number. Next, let us look into our GitHub action and GitHub action inside that CI/CD YAML. This is our GitHub actions code, and let us understand step by step. In this, we have given the Git actions name as CI/CD, and we have mentioned when the Git actions should be triggered on push into the branch main. Any changes we push in the branch main triggers our Git actions. And two files which will be ignored are helm file and the readme.md. If we commit any changes to these files, the Git actions will not be triggered. Next, we have jobs. Inside this, we have build, code quality, and push. And finally, update new tag in Helm chart. These are the basic things. For build, first it will check out our GitHub account from our GitHub and copy it, build it, same as the Docker. And next, it is the code quality. It check out the same repository, install code quality tools. That is, in this case, we have installed linit, whatever you can call it, for Go language, and it will run the code quality and checks. Finally, we have push. It will it again checkouts the code in the GitHub repository. Next, it will log into the Docker Hub through secrets. These secrets we have given it in our GitHub secrets inside the repository secrets. Next up, it will build and push actions. That is, it will build our image and push it to our Docker Hub. Once the image is pushed into the Docker Hub, the tag will be given. There will be new tag. So in order to update the tag, we have used Helm charts, as it will be variabilizing the tag. Here it again check out the code and token secrets.token it will use, and here you can see it will be changing the values in the Helm go web app.chart. Inside it values.yaml. As I have told it, it will be in values.yaml. As you can see here, we have tag. This it will be updating. Finally, it will commit and push the changes into, as these are the commands which we are using. It is fairly simple. Now that our CI part is done, let's move on to the CD part. In this case, we have installed Argo CD over here, and now in the Argo CD it has been installed, and we have given a namespace as Argo CD over here, and we have patched it to a type load balancer. As you can see here, name Argo CD server, type load balancer, cluster IP, and external IP is pending because Minikube is running in local, so it won't be showing the external IP, and this will be the port from where we can access our Argo CD login page. Next, in order to access the Argo CD login page, we can use Minikube IP. Just type in Minikube IP, you will get the IP, and port it with this 3028. Then in the Argo CD login page, you will be asked admin name and admin password. Admin name would be admin itself, but for a password you have to follow these commands to get the password. That is kubectl get secrets -n argo cd. In this, we have to edit the first file, that is initial admin secret. Once you have entered this command, that is edit secrets, this first file, you will be inside the file and you can see a password. Copy that password and it will be in an encrypted form, so we have to decode it first in order to get our password. That is, for decoding we will use echo that password pipe base64 decode. This highlighted part over here is our password for our Argo CD. If you give that and login, you will be inside the Argo CD application. Once inside the Argo CD, you will not be seeing this, but it will be blank as you have not created any application. Just click into new application and give all the mentioned files like namespaces and your GitHub repo access to this Argo application. And once you run the application, you can see over here, just a second, one your Kubernetes manifest will be automatically constructed. That is go web app. This is our name of the Kubernetes cluster. In this you can see a service deploy and ingress files which have been created, and it is healthy. And this would be our pod. Since we are given only one replica, we have only one pod over here. Now that our CD part is configured, now if you do any changes in your GitHub profile and commit it, you will see this running inside the actions. That is, build will take, like in this case it took 18 seconds for building, and code quality took 24 seconds. Push took 47 seconds, as it will always take long time because it will push the updated image into our Docker hub. It's a quite long process. And finally we will update the new tag that is pushed in our Docker hub in our mcharts value.yaml. In this case in total it took me 1 minute 33 seconds in this case after I committed a change. The change that I committed is this in the contacts. As you can see here in Kundan, the phone number and email is not added. After committing changes, you can see the phone number as 5555 and the email would be kundan@gmail.com, whereas in this it is not showing. And as the push is done, you have to come over here and just click on the refresh in order to reflect the changes made in the CI part into the CD. Then these are all the changes I have done in my execution part. Some were wrong and I have troubleshooted those changes and those errors, and I have finally been successful. Now we have come to the final, and some of the future enhancements that I can do is to add monitoring services in my application, that is Grafana and Prometheus, which would be really nice, and make it like publicly available through using cloud services Kubernetes clusters, that is EKS or IKS. Now coming to the conclusion, it was really fun to do this project with my teammates, and I am thankful for this opportunity provided by our internship providers, that is Roman, IBM, Vadvani, and IIT Guwahati, and one more company. I am not able to recall the name of that company right now. I am really thankful, and here I will conclude the project explanation.